In this lecture, we'll talk about the deauthentication attack, which is an attack of type denial of service that targets the communication between a Wi-Fi client and the wireless access point or router. The IEEE 802.11 protocol defines a special management frame called deauthentication frame. This frame is sent by an access point to a station as a sanction technique to inform the station that it has to disconnect from the network immediately. The deauthentication attack works on WPA2 despite encryption. To perform the attack, the hacker does not have to know the Wi-Fi network password, and there is no need to be authenticated or connected to the network. These frames are not authenticated or protected in any way, and anyone can inject them into the network. Note that WPA2 does not encrypt the headers of the packets, only the payload. Also note that the deauthentication attack isn't some special exploit or bug. It's built in the Wi-Fi protocol to be used in real-world applications like client disassociated due to inactivity. Many times this attack is the starting point for other attacks yet to come. One of the main purposes of deauthentication used in the hacking community is to deauthenticate the client to capture the WPA2 four-way handshake by forcing the user to reconnect to the network. The WPA handshake is used to crack the wireless password and is exchanged only at the beginning in the authentication phase. We'll have a dedicated lecture on this topic later in the course. Other purposes of this attack is to force the user to connect to the hacker's rogue access point or to a captive portal. This is also called the evil twin attack. Of course, it can only be a denial of service attack, and there were cases when the user were continuously disconnected from the network at conferences. It was also the case when Atlas and other companies have launched deauthentication attacks on their own guests, the purpose being to drive them off their own personal hotspots and force them to pay for on-site Wi-Fi services. Okay, let's get started. I'll show you this attack live. I set up a wireless network called HackMe special for this lab. Both my mobile phone and the Windows recording machine are now connected to that Wi-Fi network. The attack will be performed on Kali Linux. Before continuing, note that you need a card that supports monitor mode and packet injection. Remember that you cannot use monitor mode on Windows. I'd recommend you to watch the previous lectures where I've explained how to check if the Wi-Fi card supports monitor mode and packet injection. So the first step is to put the card into monitor mode. This is the Wi-Fi interface, and I'll use Airmon-ng to put the card into monitor mode. First, I want to see the process that could interfere with putting the interface into monitor mode. So Airmon-ng check, and I'm killing these processes. Airmon-ng check kill. Okay. The next step is to put the interface into monitor mode. Airmon-ng start and the name of the interface. WLAN 0. Now the Wi-Fi card is working in monitor mode. I'm checking it with iwconfig. Perfect. In the next step, I'll sniff the Wi-Fi traffic to identify the network and the targets. Aerodump-ng -i and the name of the interface. Now the name of the interface is WLAN 0 mon. I'm sniffing Wi-Fi traffic. Okay, it's not looking very well, so I'm changing the theme. I'll use Kali Dark. Okay, it's better. This column, called BSSID, lists the MAC addresses of all access points in the range. There are so many Wi-Fi networks in the range. I want to narrow down the results, and I'll sniff only the traffic for that network on the channel the network operates. So only for Hack Me on channel 1. This is the channel column. So I'm adding --BSS ID and the MAC address of the access point. And -C from channel 1. And it's sniffing traffic only for this Wi-Fi network on channel 1. In this section, you see the clients that are connected to the network. By the way, if you don't see the clients, check that you sniff on the same frequency band, 2.4 or 5 GHz. You could temporarily disable the 5 GHz frequency like I did for this lab. In this section, we are seeing which wireless devices are connected. We have to pick an access point that has at least one device associated to it for this attack to work. In this example, I'll attack the Windows client that is connected to this Wi-Fi network. The Windows machine I am using for recording. You see that it's connected to Hack Me network. Let's check its MAC address. ipconfig/all. So the MAC address of the Wi-Fi card is this one. 30.24.32.E2.OF.59. This one, the second client in the list. I'm opening a new terminal and becoming root there as well. And I'm starting the attack. I'm gonna use Airplay-ng, which is part of Aircrack package. So Airplay-ng --deauth, the type of the attack. It can inject also other types of frames. How many frames I want to send, and I want to send a lot of deauthentication frames. Something like this. Now -A and the MAC address of the access point. -C and the MAC address of the client. Let's check it again. Okay, the second one. And the name of the Wi-Fi card. WLAN0 If you want to send continuously, you can use 0 instead of this value. Before starting the attack, I want to check that the internet is working. I'll continuously ping this address. And of course, it's working. And I'm starting the attack. The ping has stopped. And the client was deauthenticated. See how it's trying to reconnect. The Windows machine was forced to deauthenticate. The deauthentication frames are sent continuously, so the device has no chance to authenticate and to connect back to the network. When I want to stop the attack, I simply press on Ctrl+C. I've stopped it. As soon as the deauthentication stops, the device reconnects to the access point, and we will capture the WPA2 four-way handshake used to crack the Wi-Fi password. Okay, it has reconnected. And ping is working again. Okay, that's all about the deauthentication attack. In the next lecture, I'll show you how to use this attack to capture the WPA2 four-way handshake and crack the Wi-Fi key.